us the equation 2x plus 5. And in the bottom we have the absolute value of 3x plus 4. Or the minus, 3x minus 4, that is. So 3x minus 4. And again, it says use graphs and tables to figure out the two limits and any horizontal asymptotes. So the two limits they're asking us for are the end behavior asymptotes. So if this is our function, we want to know the limit as x, of f of x as x approaches infinity. And keep in mind that if I'm going to positive infinity, when I'm out at positive infinity, do the absolute values make any difference in this function? I mean, ultimately it's going to be positive already, isn't it? And so therefore this would behave like this over this with no absolute values. And we know that if it's a rational function, then it should behave like the power function that we get from dividing the leading terms. And so therefore what should it behave like? It should behave like 2/3, isn't it? Okay. And that should be the answer. And again, you can do just like I did in the previous one and put that in your calculator and see as x gets large, what are the numbers getting close to? It should be 0.66666, so on, 2/3. Okay. Or, excuse me, you can do it this way as well. Now, we got to be careful with the limit as x approaches negative infinity because it may or may not be the same thing. Normally when we have a power function equivalent of a rational function, if you will, then 2/3 is usually the end behavior for both left and right. But in this case, think about why it's not going to be, because if you put negative values in here, okay, it's still going to do the 2/3 is still valid, but these numbers are going to be on top going to be negative. These numbers on top are going to be the same numbers but positive, and therefore we're just going to get the opposite of what we got the first time, and therefore our answer should be what? Negative 2/3. So that ultimately those are the two limits that are correct, but again, you can use your calculator to help you. This is a calculator problem. It told you to use tables and graphs, so either way though you should discover that in fact we get different behavior going left and right. And of course having a limit as x approaches infinity of 2/3 gives us a horizontal asymptote of y equals 2/3. And going the other way we'd have another one, negative 2/3. So those would be our two horizontal asymptotes. And again, we could verify that with a graph or table either way. Other questions on anything on number 5? Okay. Number 10, it says find a value a so that the function is continuous. So they've given us a piecewise function. And the first part of the piece, if you will, is 2x minus 5. And the other one is what, ax squared? And this is for at what point? 2? So x less than 2 and x greater than or equal to 2. Alright, so bottom line here is that if we're going to make this a continuous function, then when we draw this line, keep in mind that the 2x minus 5 line is going to have a y-intercept of negative 5, of course. It's going to rise 2 and run 1, so we have that point. And then when we rise another 2 and run 1 would be at that point. Now keep in mind that would be an open circle there. At that point, 2, negative 1. True? But in general, it's going to look like that on the left side of that point. And then on the right side, it's going to look like a parabola. So if we want this to be continuous, though, what's going to have to be the case with this parabola? What's the one thing that this parabola will have to be true about this parabola in order for this to be continuous? Now keep in mind, don't mix up the two items that we've dealt with so far. We've dealt with continuity, and we've dealt with is there a derivative at this point. Okay, we don't really care what the slope is at this point. You know, the slope here is 2, but that's irrelevant in terms of continuity. All that has to be the case for continuity is that there can't be this hole here. True? So bottom line is, wouldn't we want our parabola to essentially start at this hole? So our parabola y equals ax squared, we want that to contain the point negative 1, what? Negative 1 for y and 2 for x, wouldn't we? If it contained the point 2, negative 1, then we'd be good to go, wouldn't we? So ultimately with that, we're able to calculate what x would have to be, or a I should say. And so a would have to be negative 1/4. And just to make sure that works, if we say that our answer here is negative 1/4 x squared, if we were to put a 2 in there, we'd get 4. And 4 times negative 1/4 would be negative 1, wouldn't it? Okay, and so therefore 2, negative 1 would fill in that hole. And then from there, you know, the parabola is going to do, you know, whatever it does here. We could put 3 or 4. I mean, if we put 4 in there, we'd get 16 times negative 1/4 would be 4. So we get 4, 4, if you will. And so ultimately has some shape like that. But the key element here though is just to make sure that we fill in that hole that was left by the line. Okay, it's gonna have to start at that point. So if we can make the parabola start at that point, then we'd be continuous, wouldn't it? And like I said, does it have anything to do with slopes here? Continuity? Continuity is, at any point, is that we have a limit, have a function value, and the limit and function value are equal. Does it have anything at all to do with slopes? No. Right? So, anything else on number 10, question-wise? What else? Number 8, it says we have a function that's e to the x minus 2x cubed plus 15x. And the question is find a simple basic function for the right end and left end behavior model. To model this, I should say. And remember the first step on this, if they don't tell you what it is, we need to look at the graph and see what we think might be a reasonable answer. And in our experience, the answer has generally been maybe one of these terms, possibly. Okay. So if we type in r e to the x minus 2x cubed plus 15x, and we check out the graph. And I'm going to zoom out a little bit here just so we can maybe get a better look at it. Okay, so not a great look, but we can see that ultimately it kind of looks almost like a cubic function essentially. Right? So the question is, what is it going to behave like at infinity? Well, it goes up at infinity, so we probably should not expect that it's going to behave like negative 2x cubed. True? Maybe 15x, but it looks like it's going to go up more than a 15x slope though, doesn't it? So what would be the most likely candidate for the answer here? Yeah, it looks like maybe e to the x. And if you graph e to the x, I'm going to zoom back in on that just so we can see if I zoom in on that. And if I graph e to the x along with it, we might be able to see if that's, again, a reasonable guess. And ultimately, with this being over here and this being over here, it's pretty tough to see, but the behavior type is essentially the same. So, like I said, that's probably our best candidate based on the three options that we have here for the terms of this. So remember, the way we show that is we take the limit as x approaches infinity of a ratio of the two, the original problem, and what we think the answer might be. And then from there, we separate into e to the x over e to the x minus 2 to the x cubed over e to the x plus 15x over e to the x. And then evaluate each of these separately. Well, in this particular case, we have 1 because e to the x over e to the x is 1. And then what about this one? If we have x cubed and the e to the x on the bottom, okay, we know that ultimately the e to the x is going to be a faster growing function, so these numbers would be getting bigger than the top numbers. Okay? Even if this was 2x to the 3 million, okay, the e to the x is going to outgrow it at infinity. Okay? So therefore, this is going to be bigger numbers on the bottom, so it's going to go to 0. And this number 0, so therefore we get 1. And so what does that tell us about our conjecture that this is the right answer? So that means the right end behavior model is e to the x, if you will. Alright, now going to the left, the e to the x function goes to 0 going left. Okay, this function clearly doesn't go to 0. True? So therefore that can't possibly be the answer for the left end behavior, but what else might be? Out of those three choices, what behaves like this, goes up as we go to the left? Not the line either, so we narrowed it down. Pretty much got to be the negative 2x cubed, right? So let's try it and see if it works. So if it is in fact the answer, then as x approaches negative infinity, our ratio e to the x minus 2x cubed plus 15 over x all over negative 2x cubed. See how that works. So if we go limit as x approaches infinity, e to the x over negative 2x cubed minus 2x cubed over 2x cubed plus 5x over negative 2x cubed. that. And then starting term by term, whoops, negative infinity there, so negative infinity. E to the x, we know at negative infinity goes to 0. This one grows, so the answer to that part is 0. This part is going to be plus 1, because we have a negative divided by negative, same thing. And then how about this? Ultimately, it's going to be minus again, but the cubic is going to grow faster than the linear. So therefore, this is going to be also what? Also 0, and therefore we get 1 again. And so we can be assured that our left end behavior model is negative 2x cubed. Questions on number 8? Any part of the steps that I took to not only decide what might be the right answer, but also to illustrate that it is, in fact, yes, the right answer.
So if one of those ends up being 0, would that mean that that's not the right answer?
Yeah, had we gotten something other than 1, remember the key is that it's 1. Okay, anything other than 1, positive, negative, fraction, whole number, decimal, 0, then it would be a no. Yeah. So it has to be 1, because remember the whole premise behind this, the reason why it needs to be 1 is because if these two behave the same at infinity, if these two are in fact the same function at infinity, then when we divide them, we get what? We get 1. True? If these two are the same function and we divide them, okay, we don't even know if they are, but if we divide them and we get 1, then we know they're the same. True? Others, so number 8. Okay, on number 7, we have says find the vertical asymptotes of the graph. We have 3 minus x, and at the bottom we have x squared minus 16. So this is our function, and it says find the vertical asymptotes, number 1. Okay, and again with the bottom being factorable, if we factor the bottom and get x plus 4, x minus 4, we can see that nothing is going to cancel out on the top. So although they're both vertical asymptotes, so we'd say that x equals negative 4 and x equals 4 are both vertical asymptotes for this situation. Okay? And then the other part is to describe the behavior of f to the left and right of each vertical asymptote. So at this point, then we start writing a paragraph about describing them, right? When they say describe the behavior around asymptotes, what do we need to do? We're going to write a paragraph? Say when it gets close to this, we're going to start writing words down? No. We're going to use what? Limits. So we're going to say limit as x approaches negative 4 from the left, limit as x approaches negative 4 from the right, and then we're going to say limit as x approaches 4 from the left, I'll start with, and then limit as x approaches 4 from the right of our function. And then each of those are going to have an answer, and how are we going to tell what those answers are? Graphing it would be a pretty good way, wouldn't it? And what are all 4 of these answers are either going to be what? They're either going to be infinity or negative infinity. Okay. I don't know what they are off the top of my head here. Actually, I have it right in front of me. I guess apparently it should be both the left-hand limits are infinity, so that one should be infinity and that one should be infinity, and both the right are negative. And again, you can verify that by punching that in your calculator and seeing what is it behaving like as we approach from the left to the right. Questions on number 7? What else? On 11 it says sketch a graph function where f of negative 2 exists, and the limit at negative 2 is equal to 2, but it says that f is not continuous at negative 2. So again, we got to satisfy 3 criteria. There has to be a function value, there has to be a limit, but it can't be continuous. So at negative 2, okay, wouldn't something like that would certainly have a limit, wouldn't it? Okay. And the limit needs to be 2, it says, that's why I put it there. So we'll say that's our 1, 2 there. So it says the limit needs to be 2. Okay, the function value has to exist here, but it can't be continuous, so where am I going to put my circle? above or below, so I can put it right there, would be okay, wouldn't it? Wouldn't that satisfy all those criteria? What else? Work? Now 9 it says find the point of discontinuity and tell what type it is. Well, similar to what we did up top here, we when we did these two, when we did the algebra, if you will, the only algebra available, nothing canceled out, so that made those vertical asymptotes, which the type of discontinuity would be an infinite discontinuity, keep in mind. So for our purpose in number 9, we have x squared plus x minus 2. And at the bottom we have x squared plus 5x plus 6. And so if we try to factor and see if anything will drop out this time, we have x and x plus 2 and minus 1. And this one will be plus 2 and plus 3. And again, like I mentioned before, pre-calc stuff like being able to factor polynomials, quadratics like this is something that we should be able to do in our sleep. And if it takes you 5 or 10 minutes to get that done, that's not okay. You'll never get done with the AP test. So if this is, again, a skill that you need to practice, just simply factoring in quadratics, okay, let me know. And we can print sheets that are a mile long for you to practice and make sure you can do these quickly. Okay, but like I said, this should take very little time to get that done. And ultimately, since we can cross those two out, what does that tell us about x equals negative 2? That discontinuity would be a what? It would be a hole, okay, which again is removable. Or the type of discontinuity is removable. On the graph, it's a hole. At x equals negative 3, we can't get rid of that one, so that one is an asymptote. And again, when the question is posed, though, it asks us for what type of discontinuity. Remember, this is what the graph shows, and this is the type. Okay, so the parentheses is what the type is. So make sure if you're answering that question and they say what type of discontinuity, the type of discontinuity is not whole. Okay? The type of discontinuity is removable. The type of discontinuity is infinite, or jump, or oscillating. Questions on number 9? That one would kind of been a giveaway what to write because they gave you 4 choices there. What else? Number 13, we have the average rate of change. Again, the average rate of change is a matter of calculating a slope. So as soon as we see that average rate of change, first word that should come to mind is slope. Okay? It's just a slope. So if we go x squared, cubed is it? X cubed minus 2x plus 4. And the interval they're asking us to use is negative 3 to 5. And remember, when they give us this interval, they're giving us a set of x values here. We're going from negative 3 to 5. If we were to draw a picture, we'd have a negative 3 something and a 5 something. We'd draw a line to them and we'd find the slope. But we can't find the slope right now because all we have are 2 x values. I mean, we could fill in half of it. We could go 5 minus negative 3. So we can calculate the bottom half of the slope. What else do we need? We need y values. So if we plug in our negative 3, we get 27 plus 6, that's 33. Plus 4 would be 37. So negative 3, 37 would be a point. And if we plug a 5 in there, we're going to get 125 minus 10, that's 115. Plus 4 would be 119. And if we do our 119 minus 37 up top, we have an 8 on the bottom. Those two subtracted will give us how much? 119 minus 37. How much? 80. Okay. And if we divide those two, turns out to be a non-whole number here, so we would just get going there 10 1/4. Reduce the fraction. All right. And again, that's it. That's our average rate of change. This is the slope between the 2 endpoints. They give us 2 x values.
What is negative 3 to q?
Did I miss it?
27.
Where am I looking at?
X is 27.
27. You're right. Sorry. You're right. Try that again. Should be negative 27. And then plus 6 would give us negative 21. Plus 4 would give us negative 25. Sound more like it? Negative 27. So yeah, negative 27 plus 6 plus 4. Half negative 17. Okay, well, we can get through the arithmetic part. We'd be in good shape here, right? So ultimately this would be plus 17 then. So that would give us 136. And 136 divided by 8 would turn out to be a whole number. What is it? 17? Right, that's better. Okay. So either way, like I said, whether we do the arithmetic right or not, hopefully we do, because we have a calculator on, for the most part. Again, keep in mind though that that is all we're asking for on the average rate of change is just find the slope between those two endpoints. And to do that, we need to actually find the points first. All we're given is x values. We need to find the y values, number one. And then number two, once we have the points, calculate the slope. What else? 14 says find the slope of the curve. So our only means to do that is to use our limit definition. Find the instantaneous anything or the slope of the curve at a point. So if we fill in our formula here, our limit as h approaches 0, f of a plus h minus f of a all over h, and we fill in our blanks. We just put a plus h into our function, and then we just put a into our function. So step 1 would be as such. And from there, expand the a plus h all squared, a squared plus 2ah plus h squared minus 5a squared all over h. And then distribute. And keep in mind that once you've done a few of these, which hopefully we've done at least 20 at this point, we can see that when we distribute, the 5a squareds are just going to cancel out, so we really need to write the distribution step. Okay. And ultimately, if we do that, we're going to get 10a h plus 5a squared all over h. Because again, the 5a squareds and negative 5a squareds are going to cancel out. And same thing with the dividing the h out. You don't really have to factor the h out at this point. You don't have to show that. Show this step, and then from there you can just write 10a that is plus 5h. And then what is the limit as h approaches infinity now that we can directly evaluate? The answer should be simply 10a. And then from there, that part A asks us in that group, it just says find the slope of the curve, and then this is at the point 220. So let's see if we can answer our questions now. So now we have a slope formula for any point. So keep in mind that A, remember, is an x value, so does the 20 really make any difference? No, the y value of the point, who cares? All we're concerned about is the x value. Our slope formula is the slope at whatever x value is in question. So in this case, it would be 10 times 2, so the answer should be 20. Part B says to write the equation of the tangent line. Okay. And the equation for the tangent line would be y minus 20. 20 times x minus 2. And once again, I mentioned it before, and even on the quiz, some of you still did it. Okay. Why change that to a different form? There's no good reason to change it to a different form. Leave it in point slope form. Okay. Don't change it to a different form. Okay. Unless it's multiple choice, and that's what the answers are like, or if it tells you to put it in another form. Same thing with the normal line. What do we know about normal lines and tangent lines? They're what? They're what? They're perpendicular. And what do we learn about slopes of perpendicular lines in algebra class? Opposite and reciprocal. So, normal line. Again, don't multiply that crap out. Leave it alone. Okay? That's the answer. Okay. Questions on any part of that? Well, ultimately, again, like we saw in a picture, if we have the tangent line to the curve here, and then the normal line being perpendicular to it, there's going to be some applications that we'll see later where that normal line comes into play. But for our purposes at this point, we just need to know that it's perpendicular to the tangent line. Okay. So we'll get into some more with it later on. Okay. So really, like I said, all we need to know for right now is that it's perpendicular to the tangent line. I mean, it goes to the same point. Okay. But we'll get to some stuff later where we actually do a little bit more with that. What else? 15, we have, essentially the same problem. We have 3.8 t squared though instead of 5t squared. And it says that, we're assuming that the rock dropped from a 400-meter cliff. And it says find the speed of the rock at time 6. So I said the speed at a particular time is just the slope of this curve at that time. Okay? So in a sense, we just need to do exactly the same work. So if we do 3.8 a plus h all squared minus 3.8 a squared all over h and take the limit as h approaches 0, we're going to get another slope formula. Fair enough? And just because we don't have a ton of time, I'm going to go right to the answer. I'll let you do the algebra and practice that. But ultimately the answer is 7.6a. So then for our problem, we want to know the slope at what time? Time 6. So then it'd be just a matter of going 7.6 times 6. What is 7.6 times 6? 45.6. And the units here would be, keep in mind this is an instantaneous speed, which is meters per second in this case. Next. Six. Six. Let's see. 6 should be C. Anything else on the practice test?
The 400 for 15, it says 400 meters per V2 for actual something like that.
Do the what with it?
We do nothing with that.
Yeah. That really doesn't, it's irrelevant, isn't it? I mean, I could drop from a 1,000-foot cliff, my speed would still be that same speed after 6 seconds, right? If it was a 3-foot cliff, then the speed would probably be 0 because it would be underground, right? We're just illustrating that it's a big enough cliff to be able to actually do this. What else? Okay, a couple things.